In this video, we will review the steps necessary to put the Anritsu MP1900 BERT into an error-free loopback between the generator and the error detector, running at 53 G-baud Pam4. To do this, we want to make some simple connections between the pattern generator and the error detector, as well as some other modules in the mainframe. This is a typical configuration with the synthesizer driving the jitter modulation source clock input, and then the jitter modulation source clock output driving the clock input of the pattern generator. We will not be clocking the error detector externally. Instead, we will use the integrated clock recovery function. And for the data output and input, we've got a differential V cable, or actually two. We have a skew-matched cable set between the pattern generator data outputs and the error detector data inputs. This is an 80 centimeter cable set. Okay, so let's go back to the user interface. And we're going to do this from an initialized state. So from the menu, we want to select Initialize. Acknowledge this message. Initialization wipes out any settings that kind of might be getting in the way of something you're trying to do. Sometimes something may not be right, and you'll achieve maybe a sync loss state or errors where there really shouldn't be. You can't find the setting. Just initialize the box, and that puts it into a state where it is very easy to loop it back on itself, because it does wipe everything out. So from there, we want to retract to this menu and then click back into the user interface. We are going to make some minor changes. First of all, we're going to change the bit rate, or the baud rate in this case, to 53 G-baud. Also, since I'm using an 80 centimeter cable set, I want to select the correct one for the generator. Acknowledge this message. Okay, on the error detector side, we are going to do a few things. I just want to change this to an untimed acquisition. And on the input tab, I am going to set the input condition to differential 50 ohms, and also set up the clock recovery function for the error detector, and tell the error detector that I would like the clock recovery set frequency to track the pattern generator rate setting. That way I never have to change the error detector clock frequency. And then we'll jump back to the result tab. And what I like to look at is the input settings. That way I could watch my input thresholds change as we initiate an auto search. So with all of those changes made, we can turn on the output of the generator. We can see that the clock loss indicator has gone away. And from this point, we want to initiate an auto search. So we will do a coarse Pam4 auto search. We will be manipulating threshold and phase. Make sure this button is turned on, and we'll start. Okay, at this point, let's see if I move this out of the way, we could see that thresholds for the middle, upper, and lower eyes are being adjusted to optimize the bit error rate as measured by the error detector. We can see that these numbers are shifting up here, and the MSB and the LSB, they were changing as the thresholds were adjusted. Once the auto search is complete, we can close this window and restart the acquisition. And right there, you can see we have achieved an error-free state. From this point, you could look at additional details provided by the error detector, which includes a breakout of the MSB and the LSB, as well as the symbols and the symbol errors that you may be encountering. And that's it. Those are the steps needed to put the MP1900 into a Pam4 error-free loopback from an initialized state.